You'll have to excuse me for a bit. I'm recording this with a cold. I couldn't wait for it to go away. But we're moving on into chapter 9. So this is going to be matrices. And then we're going to learn first how to solve a matrix. And then we'll do a little bit more on solving matrices and other things as we go along. Well, a matrix is used to display information, and primarily what we're going to use it for is solving linear equations. So a matrix, which in plural is matrices, is what we call a rectangular array. The information in the array in rows and columns and placed in brackets. So there's a big bracket around everything. The values inside it are going to be called elements. So this would be a row, row 1, or sorry, column. That'd be column 1. This would be column 2. We don't usually talk about the columns for what we're doing. This would be row 1 and row 2. We will use rows quite a bit though. And each one of these is considered an element. The first step in solving a system of equations using matrices is to write the augmented matrix. So an augmented matrix has a vertical bar that separates columns into two groups. And primarily what ours is going to be is to represent an equality. So it's going to look like that. Like I said, this vertical bar is going to separate the group. The coefficients of each variable are going to be placed on the vertical line and the constants are placed on the right. And if any variable is missing, it gets a coefficient of zero. So we'll give you a set of equations to show you what we're talking about here. If I have this system of equations, 3x plus y plus 2x equals 31, then how I'd write that is I would keep my coefficients. Change my color here. I keep my coefficients, so I got 3 here. There's that invisible 1, a 2, and that 30. So like I said, this vertical bar is representing the equal sign, but I just write the coefficients. So I write the 3, the 1, the 2, and the 31. If I had x plus y plus 2x equals 19, well, we got a 1 in front of that x and y, so we'd write 1, 1, 2, and then we'd write 19. So this is supposed to represent your x's, your y's, your z's, and then what it's equal to. If I had this one, so then I have 1x plus 3y plus 2z equals 25, then I would write 1, 3, 2, 25. This one here, notice that we do not have an x, it's missing. And then the second equation, I don't have an x or a y, they're missing. So for this one, I would write for the first equation, we have a coefficient of 1 on the x, 2 on the y, and -5 on the z, and it's all equal to 19, x, y, z. We have a 0 on the x here because there was no x's. We have a 1 on the y, 3 on the z, and then the 9. This one's mixing x and y, so we'd write 0, 0, and then 1 for the z, and then that equals 4. So what this array is showing you is it's just showing you a system of equations. We know looking at this is x, that's y, that's z, this is what it's equal to. So I could always take that first one and rebuild the equation. 3x, 1y, 2z equals 31. So this is the equation we're going to use for an example here. So run through this together. We have a 1 here in front of the x. So remember our first column is going to be x. So we write that 1. I'm going to do this a little differently. So if I went to the next one, my column for x, I have a 2. So I'd write a 2. And then here, we don't have any x. So I write a 0. And then our next column is supposed to be our y's. So we start out with a -2, a 3, and there's a 1 on this y. Then we go on to our z's. So this first equation can have a z, so we write a 0. Next equation has one z, so we write just 1. And then the last one, we have -4z, so we write -4. And our last bit, we just write what it's equal to. The first equation is equal to 2, the second one 11, the last one -7. So here on worksheet number 1, pause for a moment. In this matrix, 3x minus y plus 2 equals 2, 2 plus 2y plus 4z equals 0, 5x minus 3z equals 6, and fill in my matrix, or my augmented matrix. So you may have noticed this last equation. Y is the component is missing, so this is actually representing 5x minus 0y minus 3z equals 6. But let's fill in our matrix. So if we got for the first equation, x has got a coefficient of 1, y's got a coefficient of x has got a coefficient of 3, y's got a coefficient of -1, z's got a coefficient of 2, and that all equations equal to 2. The second equation, x has got a coefficient of 1, y's got a coefficient of 2, z's got a coefficient of 4, and that is equal to 0. So okay for the equation to be equal to 0. And then for my last one, after I rewrote the equation, we see x got a coefficient of 5. Y is missing, so we say it's got a coefficient of 0. Z, we got -3z, so we get a coefficient of -3 on the z, and that one's equal to 6. Why do we care about a matrix? So one of the things we can do with a matrix is we can use it to help us solve a system of equations. And what we're going to do is it's called matrix row operations. So matrix with ones shown in the main diagonal and zeros below the one is called a row echelon form. So we have the 1 here, zeros in the remaining 2 columns. Then it doesn't matter what's here because then the next one is starting with a 1 and then a 0 below that. And the next one starts with a 1. We do this diagonal of 1s. This is representing x and a y and a z, and we're getting zeros here. So we like this form because it gives me 3 equations. This one gives me x plus 2y minus 5z equals -19. It tells me that y plus 3z equals 9. And here it tells me that z is just equal to 4. And with a system, I can use this to help me quickly solve an equation because now that I know that z is 4, I can easily find y, and then I can easily find x. We call this row echelon form. The following row operations produce matrices that represent systems with the same solution set. So 2 rows of a matrix may be interchanged. That is same as interchanging 2 equations in a linear system, meaning that I could just switch the order of my equations. The elements in any row may be multiplied by a non-zero number. This is the same as multiplying both sides of an equation by a non-zero number. And then elements of any row may be multiplied by a non-zero number, and these products may be added to corresponding elements in the other row. So this is very similar to using the addition method when we were trying to solve systems of equations. In addition method, we would take an equation, we would multiply it by a number and then add it to another equation to help us get a new one. And that's exactly what we're doing here, is just that we're doing it in this system of a matrix, but we're really just doing addition method. So 2 matrices are row equivalent if one can be obtained by the other by a sequence of row operations. So just for some symbols here, if we interchange elements, so rows is what we're talking about. So if they exchange a row 1 for row 2, then we just say row 1, row 2, row I, row j, whatever you want to say. But this could just be, I'm just replacing a row with another row. So I'm just switching the order and putting row 1 in row 3 place and row 3 in row 1's place. If I'm multiplying by number, so let's say I have like row 2 and I want to multiply it by 3. I just say 3, R2, and multiply all of row 3, 2, row 2 by 3. If I want to add two rows together, maybe multiply one by number. So maybe like I can have -1 plus row 3. This is going to go and replace your row 3. Or I might say 2, row 2 plus row 1. That is going to replace your row 1. All it's saying is I'm just multiplying one row by something and adding it to the other row. So like I said, just like addition method. So for some examples here, if I want to perform the indicated operation R1, R2, that means you're thinking about this is row 1, this is row 2, and this is row 3. So all I'm doing is I'm changing row 1 with row 2. So here's row 1, row 2, and all I'm asking you to do is flip them. No, they just switch places. That's all that is asking you to do. If I wanted to perform the following operation 1/4 of row 1, so the first one's row 1, we just take it and we just multiply everything by 1/4. So 1/4 of 4 is just 1. 1/4 of 12 is 3. 1/4 of -20 is -5. And 1/4 of 8 is 2. Fix a couple of these. They don't look like 1/4. So I just multiplied everything in row 1 by 1/4. So these are equivalent rows. It's just one, this one here is everything's up by, it's multiplied by a 4, and here everything is reduced. Let's say I want to have R32 plus, sorry, 3R2 plus 3 plus R3. Woo, that's hard to say. What I'm saying here is that for a moment, I'm going to take R2 and multiply everything by 3. So this is my R2. So we have 1 times 3, that is 3. 6 times 3, that is 18. -3 times 3, that's -9. 7 times 3 is 21. And then we're going to keep row 3. And then what we're going to do is we're going to add these two rows together to get my new row. So in the end, 3 plus 3, that's going to, or 3 plus -3, that is 0. 18 minus 2 is 16. Not, minus 9 plus 1 is -8. 21 plus 9 is 30. So that's my new row. And then we just put back the original R1. How are we going to use it? We're going to use matrices to help us solve this system of equations. So first thing we want to do is we want to make a matrix that represents this whole system of equations. Let me make myself as much room as I possibly can here. And right over here, I'm going to write my matrix. We can start with it. So our matrix would be just, we have a 2 on the x, a 1 on the y, a 2 on the z, and this equals 18. We have a 1 on the x, a -1 on the y, and a 2 on the z, and that equals 9. And then the last equation, we got a 1 on the x, a 2 on the y, a -1 on the z, and that equals 6. I'm trying to get my board just in place here. So we have 2, 1, 2, 18, 1, -1, 2, 9, 1, 2, -1, and 6. So there's multiple ways you can go about this. But what you want to do is you want to get a matrix that is in the form where we have a 1 and a 0, 2 zeros behind it, a 1 and a 0 behind it, and then other stuff here. So just some sort of symbol here. Oops, we want this one to be a 1 as well. So we want a whole row of 1s here, and then we want 0s here. So we need to figure out how to make that happen. So the first thing I did with this matrix is it would be easier to add them or easier if I already had a 1 here at the top, remember, because we want a 1, 1, and 1. So I said, you know what? Why don't I just take R1 and replace it with R2? That's going to put a 1 in that first spot for me. So then I would just have 1, negative 1, 2, 9, and then this would be 2, 1, 2, 18. And then the last row is going to stay the same because I did not try to do anything with that one. Okay. After this step, I need to try to get this to be a 0 here. So if I take this top equation and I multiply it by negative 2, so negative 2 times R1, and then I just add it to R2. This little equation here, if I multiplied everything by 2, this becomes negative 2, that becomes negative 2, this becomes positive 2, this becomes negative 4, and this becomes negative 18, all because I multiply it all by negative 2. And then what I'm going to do after that is I'm going to add it to 2. So negative 2 times 2 is 0. So my new row 2 is going to start with, let me put this in. So the top and the bottom are not going to change. All I'm doing is R2 plus 2, or sorry, negative 2 plus 2 is going to give me a 0 here. 2 plus 1 is a 3. Negative 4 plus positive 2 is a negative 2. And negative 18 plus 18 is 0. So now I got a 1. I followed by a 0. Now I just need another 0 here. So what I could do next is just take R1 and this time just multiply it by negative 1. So we're going to do a negative R1 and add that to R3 so we can get rid of the 1 here and have a 0 underneath. So we're going to see that this is going to, once again, like I said, I took my R1 and I multiplied everything by negative. So this is basically negative 1, 1, negative 2, negative 9. So we're replacing R3. So the first two rows have not changed. So negative 1 plus 1 is 0. 1 plus 2 is 3. Negative 2 plus, just a second here. Oh no, I'm good. I thought I made a mistake. Negative 2 plus negative 2 is negative 3. And then negative 9 plus 6 is a negative 3. So there's a couple ways we can go about this next part. So notice we got a 1 with 2 zeros underneath it, so we're good here. Now we need to take this number here, this 3, and I need to make that a 1 with a 0 underneath it. So what you could do as a first step is that, notice that's a 3 and that's a 3, so we could just take negative R2 and add it to R3. Meaning that this is going to be now just 0, negative 3, positive 2, 0. So now our R3 is going to look like this. We're going to have 1, negative 1, 2, 9. Then we're going to have 0, 3, negative 2, 0. Then if I have negative 3 plus, or well, if we have 0 plus 0, which is 0, negative 3 plus 3, that is 0. 2 plus negative 1 is negative 1. And then we're going to have 0 plus negative 3, so that's going to give me negative 3. So we have that one, we just need the other one. So what I could do is it starts with a 3. It's just, I'm going to say 1/3 times R2. So now I have 1, -1, 2, 9. Oops, I forgot my augmentation. 0. So 3 divided by 1/3 is 1. -2 divided by 3 is just -2/3, and that's going to be equal to 0. And then our last column is 0, 0, -1, -3. And we have our echelon or row of reduced echelon or our echelon reduced echelon form. I'm trying to say the right thing. So we got our 1, 1, and a -1 here. Oops. So we're not quite there yet. We have one more step. We want them to be all be 1. We're just going to take R3 and multiply it by negative. Oops, I forgot. Those are supposed to be red. That's fine. So we have 1, -1, 2, 9, 0, 1, -2/3 equals 0. And then we have 0, 0, 1, 3. Now we are in the reduced form. So we have all ones here. These are all zeros. Now we can get our equations. Just remember, this is supposed to be x, y, z. This is the augmentation, so this means equal. So we have x minus y plus 2z equals 9. We have here y minus 2/3 z equals 0. And then here we have z equals 3. So all we have to do is go back and find everything else. So we know that z equals 3. We just need to plug it back in here. So 1 minus 2/3 z, which is now 3. Oops, that was supposed to be a y here, not just a 1. Coefficient's 1, but that's a y there. So y minus 2/3 times 3 equals 0. That means that y minus 2 equals 0. So that means y is equal to 2. So now we know what z is. We know what y is. Our last equation is x minus y plus 2z equals 9. Now we can say that it's x minus 2 plus 2 times 3 equals 9, which is x minus 2 plus 6 equals 9, which is x plus 4 equals 9, which is x is equal to 5. So I have a solution to my system equations, which is x is 5, y is 2, and z is 3. You did see that did take quite a bit of time, so we're only going to do one other example here. So I want you to try on your own. You have this equation, which is x plus y minus z equals -2, 2x minus y plus z equals 5, minus x plus 2y plus 2z equals 1. So try to do, find your matrix for this, and then try to solve that matrix. So like I said, get into that reduced form where you have a row of ones with zeros underneath them to help you get a system of 3 equations that you can easily solve with. All right, so hopefully you took a chance to do this. Don't get disheartened if at first you struggle getting the correct answer. That happens a lot when you're trying to get used to this. What this is like the beginning of what we do is considered linear algebra. We have 1, 1, -1, and that's supposed to equal -2. Just try to get my board just right here. There goes, straight line. Then we have 2, -1, 1. So remember, this should all be x's, this should all be y's, this should all be z's, because sometimes you're not given equations set up as x, y, z. Sometimes I'll be a little off order. This should equal 5, and then this should be -1, 2, 2, 1. Sorry, I have a hard time with vertical lines of this thing. -2. So we get 2, -1, 1, 5, -1, 2, 2, 1. Like, we might not all have done this the same way. But first thing I noticed is that I got a 1 here. I'm good. This is a -1, so the first thing that would be really easy to do would just take R1 and add it to R3. I don't have to do any multiplication there. So we're gonna have 1, 1, -1, -2. We'll have 2, -1, 1 equals 5. So 1 times, or 1 plus -1 is 0. 1 plus 2 is 3. -1 plus 2 is 1. And -2 plus 1 is -1. Okay, so I got 1 0 below my 1. I just need another 0. So I need to get rid of this 2 here. So what I can do is go negative x1 plus, or sorry, negative r1 plus r2. So that means this top row here is now going to just be, oops, we need a 2 there, -2 r1 plus r2. So now this one will just be a -2. This one's a -2. So this -1 becomes +2. This -2 becomes +4. But remember, what we want back is the original line. I'm just multiplying it for a little bit of time just so I can add it into the next row. And then we're not messing with, I made a typo. Just a minute here. You might have caught that. What am I trying to get rid of? Oh, no, I had the right place. Sorry. I thought I put the wrong, I thought I put a 3 there. It's a 2. That's R2. There you go. Let me get rid of that for a second. That's where I made my mistake. Okay. So we have, we're adding to R2. So -2 plus +2 is 0. -2 plus -1 is -3. +2 plus 1 is +3. And 4 plus 5 is 9. And then the last one we didn't mess with, R3. So that is going to be 0, 3, 1, -1. Okay. Once again, just like similar to the last one, we have a 1 here. We got 2 zeros. We want to keep this number here. We want to get rid of the one below it. But we also want it to be a 1. So first thing I can do is I can just say, well, I'm going to take a -1/3 of r. I could just add them together the way they are. Technically, I should convert it as soon as I can. This is going to be silly here in a second. 0, this will be 1. 3 times -1/3 is going to be a -1. 9 times -1/3 is a -3. So if you just added R2 to R3, that was fine. Technically, I'm supposed to try to make this a 1 as soon as I can. So I need to make, I got a 1 with 2 zeros below it. Now this is a 1. I should have a 0 below it. So that means I have to go -3 R2 and add that to R1. Oh, sorry, R3 to get rid of the third row. So just go back. This needs to be -3 again, 3 and 9. Like I said, it's just a little silly. So we have 1, 1, -1, -2. Now, we said this is going to be 0, 1, -1, -3. But over here, temporarily, we multiplied it, so it is -3. So -3 plus 3 is 0, my third row. 3 plus 1 is 4, and 9 plus -1 is 8. The last thing I need to do is that I got a 1, 2 zeros, a 1 with a 0. I just need this to be a 1 as well. So just do 1/4 of R3. So I just want to make sure it's a positive 1 out there. So we have 1, 1, minus 1, -2. Then we have 0, 1, minus 1, -3. 0, 0, 1, because that's 1/4 of 4, and 1/4 of 8 is 2. So we have the equations x plus y minus z equals -2. Then we have the equation y minus z equals -3. And then we have the equation that z equals 2. Because remember, this is x, y, z, and this is the equals. So we just need to work our way backwards. So now that we know that z is 2, we'll pop down here. If I want to, we know that y minus z equals -3, which means that y minus 2 equals -3, which means y equals -1. We know that x plus y minus z is supposed to equal -2. We don't know x, but we know y is -1, and we know z is going to be 2, and that equals -2. That is x minus 3 equals -2. So x is going to be equal to, sorry, that's the equal sign. X is going to be equal to 1. So my solution is the ordered triplet where x is 1, y is -1, and z is 2. So the way we're doing this, we just keep setting this up so we know z, we go back and find y, and then we go back and we find x. We just need to make sure that we have this set up with the row operations that we just have a 1, 1, 1, and there's all zeros underneath here. That just gives us a 1 variable equation, a 2 variable equation, and a 3 variable equation. Supposed to be the next slide. So what we're going to do now is called Gauss-Jordan elimination. So in this case, what we want to do is we want to solve the matrix even further. So it's not just a 1 and 2 zeros and a 1 with a 0 below it, and then we don't care what's going on every place else. We want to make sure that everything else is going to be zeros. And then whatever X, Y, Z are going to be over here. So we want to look like this. So this is a setup where it's directly going to tell me what X and Y and Z are. So we're going to write the augmented matrix again. We're going to do the row of operations to get to a reduced row echelon form, which is what this is called. So we're going to simplify the matrix to a row equivalent matrix and reduced row echelon form with ones down the main column for the upper to lower right and zeros below the one. So they mean this first. And we're only doing this for 3 variable right now, but you could do this for other variables. Oops. Right, we're just doing row reduced. So this could be anything in here. That is okay. So we're looking at form where we just want to have 1 here and the zeros. Then we're going to do is going to get 1 in the upper left corner. Use the 1 in the first column to get the zeros below it. Get 1 in the second column. Get 1 in the second column to make the remaining column second column a 0. So basically, this is telling you we're just going to try to make everything zeros around it. So in this case, we're not going to do back substitution because we will directly have our solutions. let me do our example. Make sure I got one matches. So if you remember, we did this equation earlier, and so this has been our first example. We were doing the reduced echelon form. Echelon, there we go, form. So we did this one, and what we got down to was this equation, which was 1, -1, 2, 9, 0, 1, -2/3, 0. And then we had 0, 0, 1, 3. So that's what we had reduced to earlier. So what we're going to do is we're going to reduce this all away. And what we want to do is make sure that these are the only ones that exist. So I'm going to get rid of, I want to make that a 0, I want to make that a 0, and we want to make this a 0. So what we want to do is try to just get rid of these numbers here and make them zeros as well. Okay, so how are we going to do that? Well, what we need to do is get ourselves set back up. So we did a majority of the work just to get here already. We're just finishing this out. So we are starting with, like I said, after our first example of this, we had 1, -1, 2, 9, 0, 1, -2/3, 0, 0, 0, 1, 3. Excuse me. So notice we said we want to make this a 0, right? This is a -1 and this is a 1. So one of the things we could do here is that this is row 2. You're going to take row 2 and add it to row 1, because remember, this is going to replace your row 1. So the row that we're replacing is always the last one we write. So we are going to have 0 plus 1 is 1. 1 plus -1 is 0. Make sure I got this. Yep. And then we're going to do -2/3 plus 2. So 2 plus -2/3 is going to leave us with 4/3. That's going to be a 4/3 there. Then we're going to have the 0 plus 9. That leaves me with a 9. Then we'll write 0, 1, -2/3, 0, 0, 0, 1, 3. So the two rows come back. So all I did is I just took this row and added it to that row. And now you see that we got a 0 up here. So we want to have some more zeros. So what we also want is we want this 2 here to be a 0. Well, now it's going to be 4/3. So we have this right here. We have this one right here. So that would be easy to multiply. We use this very last one and we go, okay, so if we take a -4/3 of row 3, and then we add it to row 1. So if I do that, I multiply this by -4/3, it becomes -4/3. -4/3 times 3 is just -4. And remember, we're adding this to row 1, so row 1's the one that's going to change. So 0 plus 1 stays 1, 0 plus 0 is 0. -4/3 plus 4/3 is now 0. And 9 minus 4 is going to be 5. So remember when we did this last time, my solutions were, make sure I get them right, 5, 2, and 3. So what we expect is that this is going to say x is equal to 5, is what we got here. Let's fill in the rest now. So we got 0, 1, -2/3, 0, 0, 0, 1, 3. Look right down here. We need to keep going here. So now we want to make this a 0. We got this 1 down here, right? So all I have to do is go, well, what about a positive 2/3 R3 and add that to R2? So add to row 2. So now this is just going to be 2/3. 2/3 times 3 is just going to be 2. So the equation is 1005. Now we have 0, and then 0 plus 1 is 1. 2/3 plus minus 2/3 is 0, and 2 plus 0 is 2. And we see that we got y equals 2 now. 0, 0, 1, 3. So we've got an equation that is in the form I want it to be in. We got 1 here. Let me put my augment here. And then everything else is 0. We got all zeros here, and we got all zeros here. So what we can see is that, remember, this is x, y, z. So it's telling me that here, x is equal to 5. Here, y, everything else is a 0, right? So just look for the y is equal to the 2. Everything else is 0 except the 1 here, so we get the z is equal to 3, which is what we said. So you should have a ordered triplet of 5, 2, and 3. All right, so this is our last example. So before you set this up, remember all my other ones were set up with plus y, or x, y, z equals. So we need to make sure that we rewrite my equations so that when I do it, we have all the x's on top of each other, all the y's on top of each other, all the z's, and then what they're equal to should all be on top of each other. Just like when we were doing addition method, we did the same thing. We reorder it so we have our x, y, z on one side of the equation and what was equal to on the other side. So just make sure you do that first before you try to build your matrix. What you should have is, instead of x plus 2y equals z minus 1, x plus 2y, and then we subtracted z minus z equals -1. Instead of x equals 4 plus y minus z, it should be x minus y plus z equals 4. And of course, the bottom one didn't need to change. X plus y minus 3z equals -2. So my matrix is going to be 1, 2, -1, -1, 1, -1, 1, 4, and 1, 1, -3, -2. Okay, I'm just looking to see how I did this. Okay, there we go. I had to make little keys for this because there's a lot of little mistakes you can make doing this. So if you make little mistakes, try not to beat yourself up over it. It's going to happen. Okay. So I got a 1 right here already, so we can keep that 1. What I want to make sure is that I have zeros below it. So we need to make sure first that we could turn all of these into zeros. That is my first step here. So I make all those zeros. So the first thing I'm going to do is just take my R1, well, minus my R1, because that's a positive 1, and that's a positive 1. And we'll just add it to R2. So remember, this is just going to be, let me rewrite it here. So we're taking R1 and we're making everything negative. This is -1, -2, +1, +1. So everything changes to sign. So we are going to have, like I said, we want the original or the non-augmented version first. We'll put there. So -1 plus 1 would be 0. -2 plus -1 is -3. And a lot of -3s here. And 1 plus 1 is 2. And 1 plus 4 is 5. And then we didn't do anything with the bottom equation, so that one stays the same. So we would like this to also be a 0. And once again, I can do negative R1 plus R3 and replace row 3. So this is once again -1, -2, 1, 1. And we're going to add that to R3. So -1 plus 1 is 0. -2 plus 1 is -1. 1 plus -3 is -2. And 1 plus -2 is -1. Okay. So from here, what we should try to do is make sure that everything's 1. We got a 1 here, so we need to make this a 1, and we want to make this a 1. So I'm actually going to do 2 steps here. I'm going to take row 2 and multiply it by -1/3. And then I'm also going to take row 3 and multiply that by a negative to make that a positive 1. So 1, 2, -1, -1. Remember the last one, we were already to the state we're going to be here in a second. 0, so I'll multiply that by -1/3, that becomes 1. 2 times -1/3 is -2/3. 5 times -1/3 is -5/3. And then we have 0, so we said we're multiplying row 1 by a negative, so that is +1, +2, +1 again. Now we're in that reduced row. Oh, we're not quite there yet. Never mind. Because now we have a 1 and a 1 here. I thought I was there. I'm not quite there yet. So if I take -R2 and add it to R3, we can turn this into a 0, which we want to do. So row 2, like I said, really thought this is actually -1, +2/3, +5/3 now. We're adding that to the next row. I think I made a typo somewhere, so just give me a second here. One of my numbers is not working out right. All right, I found it. It was actually pretty easy. I gotta find it again. Okay, we're good. I didn't make a mistake. So what we have here is 1. Oops, that red. I didn't make a mistake. I just went off my notes. 1 to -1, -1. So here, remember, this whole row now is this red one here. So we have -1. Oops, let's write that back in here. So -1 plus 1 is 0. So we got another 0 here. Then we're going to have 2 plus 2/3. That is going to be 8/3. And then here we're going to have 1 plus 5/3, which is also 8/3. So if we take R3 and we just divide it by 3/8, so we get everything as a 1 at the beginning, we're going to be in our form of 1 to -1, -1, 0, 1, -2/3, -5/3, and then we'll have 0, 0, 1, 1. So we have gotten the reduced form where everything is a 1 here. Now all we want to do is make sure that everything else here, we want to make this 0. Okay, so first thing I'm going to do is this is already a 1, so I want to make this a 0. Pick that up a little bit. We might have to go back around and erase some stuff. I'm going to try to avoid doing it, but we want to make this a 0 now. So the way to do that is that this is a 1. So if I just do -2 R2 and I just add that to R1. So we're going to treat this as now -2. And instead of negative 2/3, we would divide that by a -2. So that becomes a -4/3. And then we're going to multiply this by -2. So that becomes a positive 10/3. Well, that is becoming nasty. You know what? How will we do this instead? So sometimes if you notice that you're going to get something really nasty, you can go back and reevaluate what we're doing. And I think it might be easier for us to make this a 0 instead. It doesn't matter as long as these are all end up zeros in some way. What I could do instead, let's take this and make that negative or positive 2/3 R3, and then we'll add that to R2 and try to get rid of some of those decimals in there. That might be an easier path to take. So this will be a 2/3 times 1, and this will be a 2/3. So we'll have 1, 2, -1, -1, and then 0, 1. So if this is 2/3, 2/3, that's going to be 0. 2/3 plus -2/3 is going to leave me with a -1. Ah, there we go. Now we got rid of all of my fractions. Very fun. I just want to go backwards. I'm like going, wait, I can get rid of all my fractions and make an easier problem for all of us. All right. So from here, I'm going to actually erase the top. We can move the top and finish this problem off. So we're going to do yellow up here, just so we know we're doing a continuation. This can take quite a bit of time to do. So moving up here, we currently have 1, 2, -1, -1, 0, 1, 0, -1, 0, 0, 1, 1. So at this point, we just want to make this 2 and this -1 both zeros, and then we are set. So what we could do is this is already a 1, and that is a 2. Now we can do -2 R2 and add that to R1. So that means this is now a -2, and this is a +2 for the time being. So we're going to have 0, 0, 1, 1 down here, 0, 1, 0, -1. Now if we do this, -2 plus -2 is 0. Well, 0 plus 1 is going to be 1. I missed that one. -2 plus 2 is going to be 0. 0 plus -1 is -1, and 2 plus -1 is going to be 1. Okay. So last little bit here is now we just need to get rid of -1. So all I have to do is just say, well, I just take R3 and add it to R1. So I do that. 0 plus 1 is 1. 0 plus 0 is 0. 1 plus 1 is 0. 1 plus -1 is 0. 1 plus 1 is 2. So there's nothing in your homework that's going to force you to pick this form over the previous form. Just pick the one that works best for you. But according to this, we see now that x is equal to 2, y is equal to -1, and that z is equal to 1. We just want to make sure that we cover all these forms for you because your class in particular, because you're going into pre-cal and you're maybe doing calculus, more math-heavy courses, make sure you understand how to do a reduced echelon form and back substitution, and then do the Gauss-Jordan elimination to help you solve matrices. That is what we're going to have for this. And then we'll find other ways to help us maybe make it a little easier to solve some of these matrices. And then we also need to just talk about other kinds of solutions, because not everything is always one set of solutions.